Hello, today I want us to look at a question involving experimental probability, and we'll also look at a bit of expectation as an extension to this question as well. So consider this question. A biased dice is rolled 100 times and the results are shown in the table below. We want to estimate the probability of not rolling a factor of 12. Before we make a start, we need to understand that the word biased means unfair. So it means there's more of a chance of getting a certain number or certain numbers on this dice. The next thing to consider is, what are the numbers that are not factors of 12? Well, 1, 2, 3, 4 and 6 are factors of 12, so we're actually only considering the number 5. Next, we want to think about how many times the dice landed on 5. Well, it landed 11 times. We can read that from the table. If you look at the result 5, the frequency is 11. In order to state the probability of an event happening, you can always use this fraction. You put the number of successes, in this case, because we're looking at how many 5s we rolled, a success is a 5, and we put that over the number of trials, so how many times I ran my experiment, or in this case, how many times I rolled the dice. So if I put the values from this question or this trial into the fraction, the number of successes, the number of 5s, is 11, and the number of times I roll my dice is 100. That actually answers this question. 11 over 100 is the probability. I can't simplify that, so I don't need to, or I shouldn't try to if I can't. There are no common factors. I thought about this as a potential further question though. You could be asked something like, how many times would you expect to roll a value which is not a factor of 12 if you rolled the dice 700 times? Well, we've already figured out the probability of getting a non-factor of 12, and I've just added some new notation in there, a p and then some brackets. Look, that stands for the probability of not a factor of 12, the probability of rolling a number which is not a factor of 12. We already know that's 11 over 100, but what would happen if I scale the number of trials up to 700? I don't want to actually roll the dice that many times, I just want to imagine what could happen if I scaled it up. So instead of having 11 over 100, I want something out of 700. We need to spot the multiplier, because these need to be equivalent fractions, and the multiplier of the denominators is 7, which means the multiplier for the numerators must be 7. 11 times 7 would give me 77, so I would expect to get 77 5s if I carried out this trial 700 times.